All right, we're still in a non-calculator part of the review assignment. We've got a couple of improper integrals to evaluate. And I know that this integral is improper because I have a discontinuity, a vertical discontinuity at 1 here, and I'm integrating from 0 to 3, so that's inclusive of the spot where I have this discontinuity. And so let me do this. I need to split my integral into two parts, from 0 to 1 and from 1 to 3. But I kind of skipped a step. I could have written that down, that I'm splitting this into 0 to 1 of my integrand plus 1 to 3 of my integrand. But I skipped a step and went ahead and I plugged in t for 1. So I'm integrating from 0 to t, and I'm integrating from t to 3. And on this first integral, I am approaching t from below, and I know that because I'm starting down here at my number as the lower limit of integration, and I'm going up. So I'm coming in from below, which gives me a negative sign for the 1 to indicate from below. For the other integral, I'm coming in from above because I start at my 3 and I go down to the t. So I have t approaching 1 from above. So then for both of these, I have to integrate, and I get the same integrand for both, but I basically use the power rule to go up a degree from negative 2/3 to positive 1/3, and then I divide by the new degree. So when I divide by 1/3, that's the same as multiplying by 3. So you'll see that I have the exact same integrand on both of these. Now I evaluate. I have the limit, and I should do one more step, and I'm going to write this step way over here. I should have the limit as t goes to 1 from below of 3t to the 1/3 minus 3 times negative 1 to the 1/3. So when I go to 1 from below, let me make sure I did that right. I plug in t here. I did not do that right. Give me a moment to fix. So I plug in t here, so 3 times t minus 1 to the 1/3, minus 3 times negative 1 to the 1/3. And then my other integral will be, the limit, as t goes to 1 from above, of 3 times 2 to the 1/3 minus 3 times t minus 1 to the 1/3. Now, when I plug in for both of these, when I plug in the ones, whether it's coming from above or from below, the expression including the t minus 1 is actually going to go to 0. Because if I'm plugging in 0.9999999 minus 1, that goes to 0. And if I plug in 1.0000001 minus 1, that's going to go to 0. So that's why over here I was able to go directly to the negative 3 times negative 1 to the 1/3, and that gives me negative 3 times negative 1, which is what I have right here. And then in the other one, I have 3 times 2 to the 1/3, which is what I have here. And then I could just simplify negative 3 times negative 1 is 3, and then plus 3 times 2 to the 1/3. You could have easily written that as 3 plus 3 times the cube root of 2 as well. All right, number 8. What we have here, you might recognize this integrand as the witch of Maria Agnesi. So this will be the curve that looks like the witch's hat, like this. And you're basically integrating underneath there from negative infinity to infinity. So this is an improper integral because of the limits at infinity. So we're splitting this integral into two parts. First, you're integrating from 0 to infinity as t goes to infinity, or 0 to t as t goes to infinity, and then you'll add to that the integral from t to 0 as t goes to negative infinity. And as you know, 1 over 1 plus x squared integrates to the arctan. So the first integral here, I have arctan, and I evaluate it at t, and subtract out evaluating it at 0. So the limit as t goes to infinity of arctan of t minus arctan of 0. The second integral, I integrate to arctan and evaluate it first at 0 and then subtract out, integrating it at t, and that's what's happening here. And I'll evaluate that as t goes to negative infinity. Now, what you have to remember is, let me cross that. That's a different problem. So this is, the graph of the arctan of x. And you do need to know this. You need to know this because of its limit properties. Pi over 2 and negative pi over 2 are the infinite asymptotes, horizontal asymptotes. So as t goes to infinity, arctan of infinity is going to give you pi over 2. Arctan of 0 says what angle gives you a tangent of 0? That is 0. Here, arctan of 0 is once again 0. And now I'm subtracting out arctan of negative infinity. So there's my subtraction sign. And then as t goes to negative infinity, the horizontal asymptote for arctan as you go to negative infinity is negative pi over 2. So I have pi over 2 minus a negative pi over 2, which is pi, which is pretty much the coolest thing, that the area, the infinite area under this Witch of Maria Agnesi curve is another way in this world to get pi. Strange that it's also the ratio of circumference to diameter of a circle.